What's up, guys? Let's solve a little more leak code today. We're going to be doing this problem. It's called generate parentheses. Ignore this, okay? So basically, the problem states that given an integer n, we want to return all the well-formed parentheses. All well-formed parentheses of strings that you can generate with sort of like n pairs of parentheses. So for n equals 1, we're going to have basically only one pair of parentheses. And this is the only parentheses that we can make. Now for n equals 3, we have many different options that we can choose from. We can choose from this option, which is just all the parentheses inside of each other, and this one, which is two parentheses inside of one parentheses, and this one is just one parenthesis inside another parentheses with another parentheses on the side, and then this one is just that thing flipped, and then this one's just all separate parentheses. So yeah, and we may return the answer in any single order, which is very nice. And yeah, so we want to form all these correct parentheses. So how would we approach this problem? This problem is pretty hard to approach at first, but because this problem is tagged as a stack problem, why don't we consider using a stack? So how I would approach this is first, and okay, so I guess like some clarifications I would ask about the constraints, like how big is the input size? Is it possible for n to be 0? What would we do then? Would we just return nothing? And also, like, what is the thing that we're returning? Is it like a list or what? And yeah, just sort of those questions. You may return the answer in any order. Yeah, so it doesn't matter the order that we return it. And just so I understand the problem correctly, something like this would not be considered a correct solution because it's not correctly closed. So what does it mean to be correctly closed? To be correctly closed, you basically need to have a bracket following with another closing bracket. So like every time you have an open bracket, it needs to be closed. So this bracket is closed by this bracket, and this bracket ends up being closed by this bracket. Okay? Yeah, so how I would approach this problem is definitely to first start off with a sort of a idea tree, or like some sort of tree, right, of a decision tree, right? So how we're going to use the decision tree is that if we start off with a string that we can sort of like add on to, which is going to be one of the results here, right? We're going to just make a string, it's going to be one of the results here. And the idea is if we keep just like an empty string for now, our first option is actually only to add just a opening parenthesis like this. We can't add a closing parenthesis, otherwise this would always become non-valid. So yeah, so now here we have one opening parenthesis. So I'm gonna have this tracker over here open, and this is closed, okay? So we have 1 here and we have 0 here. Now if you notice, as we're adding these open and closing parentheses, our closing parenthesis value needs to always be less than or equal to our opening closing parenthesis value in any point, right? So for example, if in this point we have 2 closing parentheses, right? Well, this is obviously going to be invalid because when we have 2 closing parentheses, this thing considered is good. And then we're gonna check out this guy, and this one doesn't look that good, so we're not gonna look at that one. Okay, that's great. So this is something we should definitely keep in mind as we're making sort of our decision tree. Yeah, so if we start off with this guy, we can go either 2 ways. We could just add a closing parenthesis right off the bat, or we could add another opening parenthesis and have this, right? Okay, and now we have this. Now let's look at this case. This case is basically the same case over here, in that we could just either we need to add actually a opening parenthesis because C is already equal to 0. Well, C is equal to O, which is the number of opening parentheses, right? So we need, this one only has one case to go to. So this will become this. Yeah, so, and then this case actually has 2 cases as well, just like this. This is the same case here because our closing is actually strictly less than the number of opening here. So this actually has 2 cases that we can go to. And let's just say for this example, we could go to n equals 3, okay? So this one could go to either here. It could be either a closing, or it could end up being another opening. Another opening like this. Now, one thing to keep in mind is that we want to have n pairs of opening and closing parentheses. So what that means is that either of these values cannot exceed n, right? So if O needs to be less than or equal to n, and at the end we want it to be equal to n. So yeah, there's that. So there's this case where O needs to be less than or equal to n. So in this case, we have now 3 opening parentheses. So actually what we can only do is add closing parentheses to finish this off. So we would just finish this off like boom, 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 boom. And we notice here, we notice our opening parentheses is already equal to n. So we can only add this, just like this. So now we've completed this one, but this one has yet to be completed. So this one, how many options do we have? We notice that our closing parentheses is less than or equal to the opening, is actually equal to the opening parentheses. So actually we can only add a opening parenthesis here. So yeah. So here we have opening parenthesis, and here we notice that our opening parenthesis is actually equal to it's equal to n, which means we can only add the closing parentheses to this. So we're just going to add it like this, okay, and now we have that result. But here, okay, now it's sort of like if you kind of notice what I'm trying to do, it is very similar to that of like a DFS, right? We're going to be going on one path and then going to the end of it, and then basically we're backtracking and going and finishing the paths that are actually solvable. So it is very much like a DFS. So okay, let's continue on to this case. This case we have 2 opening parentheses. So actually we could either have a closing parenthesis or an opening parenthesis. Now this one basically has it has 2 cases as well, because we can only add 2 things. Anything will only have up to 2 cases. So in this case, we're going to add a opening parenthesis over here. In this case, we're going, actually, why don't we just go, if it's a DFS, we should just go like a DFS. Okay, so in this case, we're going to actually add a opening parenthesis. Yeah, so that's good. And we notice our opening parenthesis ends up being equal to n. So what that means is we can only add closing parentheses. So we add a closing parenthesis, and add a closing parenthesis, boom, 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 and add one more closing parenthesis, and like this. And actually, what is our stopping condition in this case? Now we notice all these guys stop when exactly when their number of open is equal to 3, and their number of close is actually equal to 3 as well, right? So now what that means is we should stop whenever O is equal to 3 and our number of closed is equal to 3. And we should just return that value and put it into results. So that's really good. We should keep that in mind. So after we get this result, right, we get a result, that's great. And then we should go here and we should check and see how this would go. So here we already added an open here, so we're going to add a closed. And in this case, we actually have 2 options, because we notice that our close is strictly less than our open. So we have 2 options. We could either add a open one here, like this, or we could add like a closed one. Yeah, we got a closed one, like this. Now I'm going to continue on to this way. We notice that the open has already only equal to 3, so we're just going to add a closed guy to here, and then another closed guy. Yeah, and that completes this one. And now this one actually has 2 cases as well you could go to. You could actually no, whoops. So they're actually equal, so we need to have it opened, right? Open, and then we notice there's 3 opens, so we're just gonna add a close now. Boom, like that. Just like that, right? So that's great. Yeah, so how are we going to put this into code is the question. So actually building these, since we're using a recursive, since we're using a a tree, I think we're going to want to do something like recursively. And I feel like the biggest thing is that we're going to have to keep track of the number of open things. Like for example, open is in any point, we're going to have to keep track of the open and close number of parentheses. For example, here is going to be like 2 close parentheses, and here is going to be like here's going to be 1 close parenthesis and 1 open parenthesis, and here there's going to be 2 open parentheses and 1 close parenthesis, right? So how are we going to do that, right? That's a great question. So I feel like what we're going to need is use a string. I might change this later, but we're going to use a string to actually build these parentheses, and then at the end we'll just clear it for the next one, because basically we're doing a DFS, right? If we're doing a DFS, we're going to be going to the end of result, and then once we get to the end of result, we can just clear the string and use it for the next guy once we add it to result. And result is just going to be our And result is just going to be a list that we have. It's going to be a list like this, right? And then we can just add like all the strings to it. Let's just see here. Yeah, so we just need to add. It's just a list of strings, right? So that's great. Okay, so how are we going to code this up? Is the question. We're gonna want to have a sub function that is basically our recursive builder. We could call it like build parenthesis, right? It's gonna be called build parenthesis. And what is this gonna take in? This is gonna take in the number of open, num open, and num close. Okay, so this is what it's gonna take in. And it's gonna make a lot of decisions based on that. So what we should start off with our base case, because I think this is the simplest. So in the case that our number of open and our number of close is actually equal to 3, then we should return true. Yeah. So if our num open equals 3 and our num close equals n, it's not 3, whoops, it should be n, because we're doing it for n cases, then we should just return, basically. We're done building it. This means we're done building the parenthesis, and we should just add it to our result. So we're gonna need a result list, so I'm gonna add that here, and we're also gonna need a current parenthesis or something. Current parenthesis equals just a null string for now. Yeah, just for now it could just be an empty string, right? So now we could just say res.append. We're gonna append the current parenthesis, or just put that in. So now that we append this, we're going to add our result here, and we're going to return it. Basically, we're done building the parentheses, right? Okay, so in any other case, we're going to be actually adding num open and num closed, right? So there's always two cases you could do. So in the case that, okay, so what do we want to start off with, right? In the first case, we have basically no what are our constrictions? We should like write down all of our constrictions, right? So we can only add. So, okay, I want to write these down here, right? So okay, if our can only add open if our num closed is less than, it's actually equal to open. Okay, if our num closed is equal to open, then basically we can only add an open to it. Okay, so that's the case we want to do. And then okay, so yeah, that's great. Okay, so num open, num close. So the idea is, yeah, so that's great. And then in the case that num open, so we could actually add both. We could add either if num closed is strictly less than num open, right? So basically we're gonna have something that looks like this. Wait, no. Wait, yeah, like this. So we have something like this. So basically we only have one that's closed. We have another one that's open. Yeah. And actually, there's also another case we need to check. And our num closed, our num open, is not equal to 3, or like less than n. Okay. So, for example, if our n was equal to 3 here, if our n was equal to, okay, yeah, if our n was equal to 3 in this case, right? If our n was equal to 3, then the idea is we can't really add any more open ones, because we would have more than 3 pairs, which is not what n wants in this case. So we would also need to check that to add here. Yeah, otherwise we can add an open. So this is the case to add an open. Otherwise, I think we should just add a closed, to be honest. So yeah, so after we check if we can add an open, we can just add a closed. So this is the condition if we want to add a open, right? If we want to add a opening, is there any other case that we could choose to add an opening? We could add closed, no open. we can only add an open. Wait, we can only add a closed. Yeah, add an open. Yeah, so we should check for this, and then also check for this, and then otherwise we can add a closed, I think. I think that'll be the best practice, I think. So, okay, so here, we're just going to check. We're gonna do check if we can add an open. Right, so we're gonna check if we can add an open. If our num closed is equal to open, then we know that they're both not equal to n, but also we know that they're equal to each other. So we should add a num open. We should add a open, right? Num open, or in this case, num closed is greater than this guy, and num open is less than n. So basically, we just paste this guy in. So our num closed is our number of open guys is greater than our number of closed guys. Now, what does that mean? If we go back to here and we go back to this example, we have like something like this, right? And in this case, we could add a open, but only if our num open is less than n. So in this case, our num open is equal to 2 and our n is equal to 3. So we can add a open. So you can see that we do add an open over here. So that is fine. We're fine with adding a open. Okay. Yeah, but the thing is, you could also add a number of closed here. Right, yeah. Okay, so the thing is, okay, in this case you can only add an open or closed. So this one is open or closed, right? So I think we should separate these, to be honest. Yeah, so this guy's like this. So this guy is only, we can add an open, right? Just only add open. And we have another case that we should check and do this later, but I'm just gonna complete this guy first. So this guy just says, basically we want to add an open. So we're gonna say current parenthesis. It's gonna plus equals a, and we're gonna add an open, right? So we added this guy. That's great. And then we're gonna want to build parentheses with num open plus equals 1, and num closed, or num open plus 1. Then num closed, okay? Because we added an open, just like that. So it's recursive. Okay, so in this case, we should check if our num closed is less than our num open, and our num open is less than n. So that is this case right here. And this case right here actually yields both results. Okay, so how are we gonna do the both results? That's a very great question. So I think the let me think for a second. Okay, so this is the guy we're adding, right? But we're gonna obviously add both. So what we could do, I think we could check for this guy and then do both in the if statement. So we do this and then we could just do okay. But we want to do a DFS, right? So it's like, it's kind of awkward. So when do we want to add an open and when do we want to add a closed? In this case, we could add either or. So how are we going to do this? Okay, it's a great question. Great question. Coding these up is actually a bit difficult. It does prove to be a bit difficult. So it's really recursive, right? Well, it's not really helping. Okay, num closed is greater than num open is greater than our num closed. So what does it mean? Okay. Yeah, so in this case, this case is met, but the thing is, when should we add a close and when should we add an open, man? If we add an open and call recursive on this guy, and we go back, call recursive on this guy. It might not be beneficial to use a stack. It might be beneficial just to use a current parentheses like this. Current parenthesis. And then we should always pass in current parenthesis like this, right? I think that's best. That's best practice. And here we could just pass in. So basically, we're gonna want to call build parenthesis. Yeah. So here in this case, we could either go two ways, and we're just gonna go two ways, right? We're just gonna go both ways. Here, so this guy's gonna go this way. This guy's gonna add an open, and he's gonna add to current parenthesis plus a open guy, and then this guy's gonna add a closed. Okay, add a closed guy like this. It's gonna be like this plus boom. This is gonna be like plus. So we're gonna add a close here. We're gonna add an open here. Okay, that's great. And then there's also a case where we can only add a close. So how are we gonna add a closed guy? That's a great question. So we should observe the case for a closed. Actually, I think the case for a closed is literally just else. Else we should just like add a closed. You know, this case just add a closed, and I think this should work. To be honest, we'll see how if there's any errors and stuff like that. But I'm pretty confident in the logic. There might be some edge cases that I need to worry about as well. In the case of one, it's obvious that we're just gonna return this guy, right? Returning one guy and close guy. So how? Okay, wait. Why don't we just go through this in our head? So in the case that we have like n equals 1, how's this gonna work? N equals 1, right? For n equals 1, the idea is we're going to first call build parenthesis. I think we're just gonna want to call build parenthesis with a 0 0 for now, and then I don't know, current parenthesis, like an empty string for now, right? Okay. Okay, so now if we have n, right? N is equal to 1, right? So obviously this stuff doesn't proc. And then we check, oh, it's equal. So we add a open guy, and then we call this guy with a open guy. So we have a open guy now, and basically we're over here, right? So here we notice that's great, and we check here, and they're not equal. Obviously, well, num open is equal, but num close is not equal, so that doesn't proc. Num close is not equal to num open, so that doesn't proc either. Now what happens here is num close is num open is greater than close. That's true, but num open is not greater. N is not strictly greater than num open. It's actually equal to, so that doesn't proc. So we get to the else and we add a closed, and we call this again, and then we come over here and we notice that num open equals n and num close equals n. So we just return and append that to the result. Append the result and return. Something should work. And what's last is just to return res. Now let's see how this works. Not the most confident. Build parenthesis. Oops, I spelled this wrong. Okay, so let's see. Okay, we have some errors, obviously. Maximum recursion depth exceeded. Uh-oh, that's not good. Uh-oh, okay. Well, that's really not good. So how am I gonna do this? Okay, so num open equals n and closed equals n. Then we should just return results here. Okay. Print hello world. Let's just see how many times it's like running. I want to have like a glimpse of like what is also going on with like num open. Well, yeah, num close shouldn't be going that high. Why is num close going so high? Okay. Obviously they're not equal. Okay. So this case, num closed is less than num n, and num open is less than n. There's more opens than closed, so we need to add either a closed or a open, because num open is less than that. Okay, so we can just do that. Now, why are we getting so many opens? So we added an open, added a closed, added an open. Oh, it just keeps adding closed. Interesting. Now, where are we calling this? Where is this guy? Okay, it was obviously not here because this thing's like this. So actually it ends up being here. Print hello. And let me confirm my results just like this. I'm pretty sure it should just be this guy because we keep calling it. Else in this case, our num closed is less than our num open, and our num open is less than n. I don't see a problem with this. Wait, okay, so our num. So what happens when we have too many close? But we should never have too many close. So it's just so weird. Weird. Oh. There, you're equal. Equal. So it starts off they're equal and it's great, but why does it go down to here is the question. Because it prints hello. Oh, it says they're equal and it calls this guy. Wait, then we should say return, no? Return. You shouldn't call these. Oh, there we go. Wait, you can do semicolon? I didn't even know that. Let's see. Let's see if this works. I'm not confident this will work. Oh, it worked! No way! I'm the GOAT! Let's go!